next let's go on to the F block elements. For the F block elements, you should not be knowing many things. Okay, there aren't any compounds in this kind of thing. Or you should be memorized the periodic table. You should be knowing the states of like oxidization states and all. And in the oxidization states, you should be knowing both lanthanides and the actinides. So for lanthanides and actinides, both +3 is the most stable state. However, in lanthanides +4 and +2 are also observed, and whereas in actinides +7 and +6 are also observed. Okay, so going on to the lanthanides, +4 is observed by elements which are very close to the lanthanum. Okay, so silurium, promethium, presmodium and neodymium, all the three elements show +4. And also you can see that the element which is after gadolinium, that is the terbium, okay, this element here would also be having +4 oxidization state, and that is because it needs to get the half-fixed status. Means it's easier for it to get the half-fixed status by donating 4 electrons. Okay, then for +7 examples are the planetary elements, as I would like to call them, Neptunium and Plutonium. Yeah. Then +6, however, it's unstable. Okay, unstable. Then we have the +6 oxidization state, which is shown by uranium, and this is the stable element over there. Okay, +2 over here is shown by elements which are just below the halfly filled and completely filled. Okay, with the elements over here, which is europium, and over here, which is ytterbium. Okay, they show +2 in this thing. Correct? Right. Now, leaving this, you also have some other properties like color. Another example is color. So for color, you should be knowing that 4Fn and 4F 14 minus N, same color. Okay. Then another thing you should be knowing is that 4F 0 F 14 and F7 colorless. However, this may not be correct to say that F7 is halfly filled, F orbital is colorless. Okay, that you have to check. Okay, so moving on, that's the color. And diamagnetic and paramagnetic properties are similar as to D block elements. Halfly filled are highly paramagnetic, and those having no lone pair electrons are diamagnetic. After that, we go on next to the some other few things. For example, ionization energy increases from left to right. Okay, as you go from F0 to F14, it increases like this. Density, same. Okay. After that, boiling point and melting point. Okay, same. Then after that, you go on to this thing. Another major thing you should be knowing is the lanthanide contractions. Okay, so the lanthanide contraction is the contraction of the atoms. Okay, due to the poor shielding by the F orbital. So if the F orbital does not shield properly, what happens is that the atom, okay, the atom size will increase. The atom size will decrease because there is not enough shielding. If the shielding was good, then the atom size would increase. Because it's not, it will decrease. So, going by that logic, the lanthanide actinide contraction, you can say that it has a few problems which will happen. So, one of the first cases which will happen is the infamous zirconium and hafnium. It's having similar atomic radius. Okay, and density. Zirconium is very less than hafnium, almost double hafnium is almost double density when compared to zirconium. Okay, so that's for density. And after density we have a few more things. Uh, you have a lot of things like the alloy formation and some other things. Actually, wait, no. Before that, you also have the basicity. Basicity would decrease from left to right. Okay. This is because as the size is becoming smaller, the acidic character would increase. Okay. Uh, okay. So going on to next, we have complex formation, very less chances. Alloys and carbides, they cannot ask much. One important thing they can ask is the formation of mesh alloy. So this mesh alloy is one important thing, which is Fe plus lanthanides. There are many things you should be knowing in this. Basically, this mesh alloys are used in some cases, and another thing you should be knowing is cigarette. No, not cigarette, lighters. They have inflammable lanthanoid metals. And similarly for actinides also you have a few properties, however they cannot ask much in the actinides. And if you remember so much for D block, it's more than enough. And you should be remembering the similarities and also the dissimilarities. Okay, you should be remembering both of them, and that's all will be asked from the F block. Again, you should be knowing a periodic table, you should be knowing the color, and actually I forgot one more thing, you should be knowing finally the electron configuration. Correct? Now this, if you know, you will know everything about F block that needs to be known.